Okay, this is the algebra worksheet. I'm just going to go through these questions and try and make it a little bit clearer for you. So, this is a very typical question, although the perpendicular to the line doesn't normally come up in IGCSE. The key thing with here is that if it said parallel, then the gradient would be the same as the last one, so the gradient would be 3. If it's perpendicular, you take that 3, you flip it, and minus it, and then you get the perpendicular gradient. So we know the new gradient is minus a third. We also know that it goes through the point where x is 6 and y is 5. So if you were thinking about what it looked like on a graph, you'd have the point 6, 5, a gradient of minus a third. So it would look like that. And we know the equation would be y equals minus a third x plus something, and that something would have to be more than 5, because if this was 5, then that would be a bit more. But the way we work out is algebraic. We say we've got a basic equation for a line, y equals mx plus c. And this is the way that you always go about finding the equation of a line. Well, I say that there are tangent questions where that might not be the case. But if you've got a question in the middle of the paper, this is what you're going to have to do. You've got m equals a third, so we'll replace m with that. And we've got x is 6 and y is 5, so we'll replace x with 6 and y with 5. So that becomes 5 equals minus a third, 6, so 5 comes from here, 6 comes from here, minus a third comes from here, plus c. And now we've got an equation where we can work c out. We get 5 equals minus 2, because that's a third of 6 is 2, and so minus a third of 6 is minus 2 plus c. Add the 2 over to the side and we get c is 7. So now we know the gradient, which is minus a third, and we know the intercept, which is 7. So the final equation is just y equals minus a third x plus 7. Done. Okay. When you've got fractions, remember there are 3 things that can happen. If you've got a minus, you flip. And if you've got a fraction, the top number is the power. Let's say that's 3 for argument's sake. And the bottom number is the root. So here we haven't got a fraction, but we do have a minus. So the 2 means you square it, and the minus means you flip it. You take 16, you square it, you get 256. You flip it, so that would be 1 over 256. Here, the half, we have got a fraction. The top number is power to the power 1, doesn't change anything. The bottom number is the root, so we're taking the second root, or the square root of 16, which is 4. A to the 0, anything to the power 0 is 1. Here we've got a minus, which means we flip it, and we're doing the square root, because there's a 2 on the bottom. So we take 16, we flip it, 1 over 16, root it. Root of 16 is 4, so it's 1 over 4. Or we could root it first and then flip it. The order that you do the flip power root doesn't matter. You always get the same answer. So then putting these in order from descending order, the biggest one is this one. So it'll be a to the half, then a to the 0, then a to the minus half, and finally a to the minus 2. With 1 over 81, the results are going to be slightly different. Obviously, a to the minus 2, we flip and square. So flip it, we get flipping 1 over 81 takes us back to 81, and square it, we get 6561. For this one, the half is square root, so the square root of 81 is 9. The square root of 1 over 81 is 1 over 9. Anything to the power 0 is still 1. And here we are square rooting because of the 2 and flipping because of the minus. So flip, we get 81, and root, we get 9. So in descending order, we have a to the minus 2, then a to the minus half, then a to the 0, and finally a to the half. On to the next page. Making t the subject of the formula. So if this goes slightly out of focus. There we go, that's better. So here, whenever you have an equation like this, hopefully you'll recognize that you can just swap these 2 around. Let me zoom in a tiny bit. That's better, isn't it? So we need to swap these 2 around. So the long way around, you can multiply by t, you get t, p equals 4, and then divide by p, t equals 4 over p. But hopefully you've seen enough of these equations, particularly the SOHCAHTOA equations, that those 2 can just swap places. That's the long way of doing it, but that's the quick way. Right, here we've got t appearing twice, so we know what we're going to have to do. We're going to have to multiply across, put all the t's on one side, and then factorize out. So multiply across to get tw equals 2 plus 3t. We've got t over here, we've got t over there. They need to be on the same side. We'll move the 3t over. tw minus 3t equals 2. Now we've got the terms that contain t on this side and the terms that don't on this side. We factorize out the t. It's t times w minus 3 equals 2. And finally we divide to get t equals 2 over w minus 3. Same situation here. Multiply across, tf equals s minus t. Add the t over so the t's are on the same side. and then factorize out t times f plus 1 equals s. So t is s over f plus 1. The volume of that is directly proportional to the cube of the diameter. So that's a formula. V is directly proportional to is k times the diameter cubed. Now, is that cube root of d or d cubed? Well, it doesn't say root, so it's d cubed. If it were root, it would be there, but the word root doesn't appear. And it also tells you when the volume is 324, the diameter is 6. So we plug those in, we get 324 equals k times 6 cubed. So 324 equals k times 216. Divide both sides by 2 and 6, and we get k as 1.5. Then find the diameter of a thing with volume 12. So our formula says 12 equals 1.5 times d cubed. Whoops. Divide by 1.5 and we get 8 is d cubed. So d is the cube root of 8, which is 2. Oh, sorry, I'll do that. Yeah. To the next page. I've changed this now so it reads correctly. It's w is inversely proportional to the positive square root of t. In other words, w is k over, because it's inversely proportional to square root of t. We sub in w is 5 and t is 100, and we get 5 equals k over root 100. So 5 equals k over 10, multiply across, and k equals 50. Then we replace k in this formula, and we get w equals 50 over root t. Moving on to using the formula now we're just substituting stuff into a formula. Our formula says 50 over root t. So when t is a quarter, it's 50 over the square root of a quarter, which is 50 over a half, and that 2 goes to the top, and we get 100. Equally, t when w is 10, we've got w equals root 50 over root t. And sub it into the formula, w is 10, so 10 equals 50 over root t. And by that thing that we were talking about, we can swap these two around. So we get root t equals 50 over 10. So root t is 5, so t is 5 squared, which is 25. This question is not part of IGCSE. Let's move on. Okay, graph questions. I might need to zoom back out a little bit for this. Okay, so you've got your graph here, and it says solve this equation, graph equals 0. Whenever it's just the graph there, then its graph equals this, and whatever this is what you draw to solve it. So y equals 0 is, of course, the x-axis, so our solutions are here, and that's pretty obvious that x is minus 4 and 2. Very easy. This is still graph equals something. Here it's graph equals minus 4. So you draw a line at y equals minus 4, and you get your solutions here and here, and we're looking at x equals minus 3.3, I think. So you can have 0.1 either way, and then 1 point, I'm going to go for 3 as well. So again, 1.2, 1.4 would be tolerated. I'm going to jump ahead to part 4 because that is also of the form graph equals something. This is still the graph. Graph equals x. So what you would draw on this one is y equals x, which I'm going to draw slightly clumsily now without a ruler, but it looks like that within the range that we're interested in. And so you get solutions here at 2 point something, sorry, 2 point, what's that? 2.4, and over here at minus 3.4 as well. This line's thicker than it would be in the exam, so it is slightly ambiguous. There is another way of doing that one. I'll come back to that again. This one is different, though. This is not the graph. So when it's not the graph, quack to goose. There's your question. You write the graph underneath, which is x squared plus 2x minus 8, and you work out how you get from the question to the graph. So from x squared to x squared, no change. From 2x to 2x, no change. From minus 10 to minus 8, you have gone up by 2. So we are looking for y equals 2. So we draw that on the graph, and we get solutions at minus 4.4 and over here at 2.4. Now, I said that you could do this one by noticing that it was graph equals something and just drawing what's on this side. We could do it by the slightly longer method to make sure. So some people prefer to make this equal to 0 first. That's fine. They would have done it for this one as well, potentially. So you bring the x over and you get x squared plus x minus 8 equals 0. And then you say that's your question and you write the graph underneath. And then you see that to get from x to 2x, you've added x, and so we ended up back where we started. It depends. Some people are not comfortable with spotting that its graph equals that. That is the quicker method. But if you, whatever question you have, if you rearrange it to make it equal to 0 first and then move from question to graph, if that makes you feel more comfortable, it will work. The last one, it's another quacked goose. The question is different from the graph, so we write the graph underneath, x squared plus 2x minus 8. And from x to 2x, we've gone up by x. And from minus 3 to minus 8, we've gone down by 5. So we're drawing y equals this, y equals x minus 5, which is just a line of gradient 1. Normally with these questions, the x and the y scale are different, so you have to be careful with that. It just so happens that in this particular one, y goes 1, 2, 3, 4, 5 at the same rate that x goes 1, 2, 3, 4, 5. So anyway, that's the line. I'm just going to draw it very roughly, and you get the values of minus 2.4 and, I don't know, 1.4, something like that. I'm just rushing through it, but I think the proper answers are in the answer sheet. So you get a tolerance of about 0.1 on those. It's quite strict. Right, factorize these. Okay, so the first one, let's zoom in. You've got the, oh dear, come on, focus. There we go, that's better. X squared minus 36, it's something squared minus something squared. So what's the square root of x squared? What's the square root of 36? And then plus and minus, done. This one, they're giving you a bit of help. This is something squared minus something squared, but slightly awkwardly, they have a common factor. So you take out the 2 first. So it's given you that it's 2 times a squared minus 25. Some people thought that they'd written down the answer. That's not the answer. A squared minus 25 does factorize. Again, that's a square, so we do 2 times the square root of a, sorry, I've just written x, a squared, and the square root of 25. And then it's plus and minus, that's done. These ones, there is no common factor, so it's not quite the same, but 4s squared does square root, so it goes to 2s. And 9t squared also square root, so it goes to 3t. And then you stick a plus and a minus in the middle. Quadratic, which doesn't have x squared, so you can't do times to get 3, add to get 7, it doesn't work. We can use the cunning method. Some people will just be able to look at this and factorize it. If you can, great. This is the method I like. If it isn't obvious, you do this times this, and so 2 times 3 is 6. We're looking for 2 numbers that multiply to make 6 and still add to make 7. So if you're thinking of 2 numbers that multiply to make 6 and add to make 7, hopefully you'll realize that's 6 and 1. It's all plus. So now we use 6 and 1 as our numbers, but instead of writing x and x here, we write 2x and 2x here. These are plus, by the way. And then we cancel down any of these we can. This one goes to x plus 3, and that's our answer. There are other ways of doing that. You can use the quadratic formula, which would give you x is minus 3, which would give rise to this, and x is minus a half, which would give rise to this. This one, again, let's use that method. So 3 times minus 4, we're looking at 2 numbers that multiply to make minus 12 and add to make 1. So the numbers, because one's positive and one's negative, effectively we're looking at numbers that are 1 apart. So 3 and 4, and because they add to make 1, it's the plus 4 and the minus 3. So we've got plus 4, minus 3, and we put 3y and 3y. Do any of these cancel? Yes, 3 minus 3 does. So it becomes 3y plus 4y minus 1. Oh, here's another one. 5 times 2 is multiplies to make 10, and adds to make minus 11. Oh, I've written minus there. Adds to make minus 11. So if they add to make a negative number multiplying a positive, they're both negative. So 2 negative numbers that multiply to make 10 and add to make 11, it's minus 10 and minus 1. And then we put the 5x here. And this one cancels down to give you x minus 2. Done. Okay, on to the fractions. This and this don't have any factors in common. We're just going to have to multiply them together to get a common denominator. Whenever we add or subtract, you have to work in a common denominator. So x times x plus 2 and x times x plus 2. If we take the first one to multiply it from x to get x times x plus 2, we've multiplied it by x plus 2, so we do the same to the top. So we get 4 lots of x plus 2, which I'll write as 4x plus 2. I'm going to do the slow way. And then this one to get from x plus 2 to x times x plus 2, we've multiplied it by x, so that becomes 6x. Now we can add the tops, so 4x plus 2 is 4x plus 8. Add 6x. All over, click those together, common denominator. X times x plus 2, we'll leave the bottom factorized. And so 4x plus 6x is 10x, and 8 is by itself. Does the top factorize? Yes, there's a 2. Is it any of the factors then common bottom? No, so we can leave it like that. If there were, then we can cancel it down further. Hence or otherwise, solve this equation. Okay, so if you're solving this, you've got 10x plus 8 over x times x plus 2 equals 2. This is where it gets a little bit tricky. Now, normally you don't multiply this out, but now I would suggest you do. So you get 10x plus 8 over x squared plus 2x. I would do that before you multiply, just because it makes it less confusing when you actually bring it over. So we get 10x plus 8 equals 2 lots of x squared plus 2x. Or in other words, 10x plus 8 equals 2x squared plus 4x. Now, because it's quadratic, because the x squared, we need to bring everything over to the same side and make it equal to 0. So we'll bung it over here, and we get 2x squared, minusing the 10x, we get minus 6x, minusing the 8, we get minus 8, equals 0. And it's a non-x squared quadratic, but this is all divisible by 2, so divide 0 by 2, still 0. Divide that by 2, we get x squared minus 3x minus 4. And that does factorize. We get x minus 4, x plus 1. So our answers are x is 4 or minus 1. Quadratic formula time. So x equals negative b plus or minus the square root of b squared minus 4a. Now this is where the problems start. B squared minus 4ac. Let's just write out a is 1, b is 5, c is 1. Easy to make a mistake here, so let's make sure we get this right. B squared is 5 squared, which is 25. 4ac is 4 times 1 times 1, which is 4. So b squared minus 4ac is 25 minus 4. I think it's a good idea to write 25 minus 4 in here because they like to see that and you're working in the exam. All over 2a, which is 2. So x equals minus 5 plus or minus the square root of 21 all over 2, which is whatever it is. You can bring it into calculator. Likewise for this one, we've got a is 1, b is minus 10, c is 4. B squared is minus 10 times minus 10. Careful, that's plus 100, not minus 100, because all numbers squared are positive, unless you're talking about imaginary numbers. And 4 times a times c, don't worry about that, that's in further A-level maths, is 4 times 1 times 4, which is 16. So b squared minus 4ac, which is the most important number in the formula, is 100 minus 16, which is 84. So we are talking about x equals negative b plus or minus the square root of that all over 2a. Which comes to whatever it comes to. That actually simplifies down to a very similar answer to that one. Anyway, this last one, we can't do the ABC yet because that's not a 0. All quadratic equations, we start by making it equal to 0. So we minus the 2 over, we get 2x squared plus 13x minus 7 equals 0. So now we've got a is 2, b is 13, and c is minus 7, which means that b squared is 13 squared. 4 times a times c is 4 times 2 times minus 7, which is minus 56. And this time, b squared minus 4ac is 169 minus 56, which is 225. That actually is going to square it to give you a positive number. So we get x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And that's 15. So we get minus 13 plus minus 15 over 4. So I actually bothered to do this one. Minus 13 minus 15 over 4 is minus 7. And minus 13 plus 15 over 4 is a half. Okay. Moving on. Ooh, finding the mistakes with Merrill's solution. Okay, so let's just check. We've just gone through this and we know that a is 2, b is minus 10, and c is minus 8. And so if we were working this out, we would say x equals minus b, which would be 10, plus or minus, now let's work out our b squared and our 4ac. b squared is minus 10 squared, which is 100. Remember, it's always positive. 4ac is 4 times 2 times minus 8, which is minus 64. And so b squared minus 4ac would be 100 minus 64, which would be 164. Okay. Now that we've worked it out for ourselves, let's just go through this and check that it's all correct, which of course we know it isn't. All over 2a, of course. Now, here's the first one, 2a. Well, a is 2, so 2a is 4, so that should be 4. First mistake. X equals negative b. Well, b is negative 10. That's clearly still negative 10, so that should be 10. minus 10 squared. And now, if you type in minus 10 squared, your calculator will say it's minus 100, but you are squaring the number minus 10, so that should be in brackets, and that number should be plus 100. And finally, it's minus 4ac, which is minus 4 times 2 times minus 8. That's right. But because that's negative 64, it's 100 minus minus 64. So that really should be plus. Hopefully, you guys managed to spot some of those. Anyway. Solve the following by completing the square. Oh, I didn't realize completing the square was in this. Okay. You don't need to do this, but I'll just do it very quickly. This is not in your syllabus. X plus 3 squared minus 9 plus 2, so x plus 3 squared minus 7. Look up Bollywood quadratic if you don't want to know how to do this. And so we get x plus 3 squared equals 7, and x plus 3 equals plus minus root 7. So x equals minus 3 plus minus root 7. You really wanted to know that. We can go through this, but to be honest, it doesn't matter. Sorry, I should have picked that up before. Show the area of defect. Okay, people really struggle with this type of question. This is an algebraic, and also, what's going on with the labels of the sides? This is really confusing. That 4 could be anywhere, couldn't it? Crikey, I'm trying to work out what exactly is going on. I think for it to make any sense, that 4 would have to go here, but I apologize, this is pretty ambiguous, isn't it? So if that's 4, then that makes this length 2x here. Presumably, if that's 4, then this is 2x. This may not work. So this would be 2x times 3x plus 2. So a would be equal to 2x times 3x plus 2, which would be 6x squared plus 4x. And then this would be 4 times 2x minus 4, which would be 8x minus 16. So if you add the two together, a plus b, we do indeed get this, don't we? 6x squared plus 4x plus 8x minus 16, which is 6x squared plus 12x minus 16. Now, I admit this is not clear which one it belongs to, and that one's not clear which one it belongs to. It looks like the 4 should be there. But if the 4 were there, then you'd know that this was 3x plus 2, and that was 2x minus 4, so you'd be able to work out what x was, and it wouldn't make any sense. Apologies, that's a little bit ambiguous. If the area of the shape is 20 centimeters squared, find the length of the longest side. So hopefully, even if you couldn't get the first one, you should be starting to get confident enough in your algebra to say, well, okay, I couldn't do the first bit, but I can use the result in the first bit, even though I didn't prove it, to find the second bit. So we know here that the area is this expression. That's an expression for the area in terms of x. And we're saying if the area is equal to 20, i.e. if that equals 20, we can solve this equation, right? We don't even know what the use of it is yet, but we can solve it. So we do 6x squared plus 12x, bring over the 20. And although this looks pretty bad, it's all divisible by 6. And that factorizes. Wait, what am I doing? Plus 2? Whoa, moment of complete panic. Yeah, it's going to be quadratic formula, isn't it? Sorry. So we get x, I'm going to do it by completing this. No, I should do it by the quadratic formula, because otherwise you won't know what I'm doing. X equals negative b plus or minus the square root of b squared minus 4ac. Then you divide it all by 2a. So x equals minus 1 plus minus root 7, which is whatever it is. That's about 2.4. So we're looking at like minus 3.4 or 1.4. Now, because one of these values is negative, and we're looking at x referring to length here, clearly the value where we get minus 3.4 isn't going to work, because that would make these lengths negative, and you can't have negative length. So in this particular case, and this is quite common with this kind of question, we can only use the positive one. This is invalid. And so we take x to be 1.4, or whatever it is, whatever minus 1 plus root 7 is. And then it wants the length of the longest side. Well, if x is 1.4, you could sub it into all of these and work out what the longest side is. But I hope it's obvious that it would be the 3x plus 2 one. So the longest side will be 3 times this plus 2. 3 times 1.4 plus 2, which is about 6.2. Actually, it might be the case that this one's slightly longer. Sorry, I thought this was clearly the longest one, but if you do 2x plus 4, that's 3x plus 2. If we do 2x plus 4, we get two lots of 1.4 plus 4, which is actually a bit bigger. It's about 6.8. So sorry, I assumed that would be the longest side because it had the most x's, but in fact, this is the longest side. You might have had to plug it into all of them just to be sure. That's quite a hard question. But this algebraic reasoning is something we need to practice, and we'll go through it again in more detail. Okay, match the correct function to the correct graph. Ooh, do you know what? This one isn't really in the syllabus either, because this involves completing the square, and it's something we haven't done, so apologies. I should have paid a bit more attention. This is for GCSE, which is a bit harder. And that's it. Okay, well, hopefully that explained it. Apologies for questions 14, which was outside your remit, and also for question 12. I'll post now that you don't have to solve those. But yeah, please do ask any questions, and best of luck.